I'm so not ready for this. Okay, we're doing it. All I want to do is be like, okay, kids, we'll stop here and take it up tomorrow. Can't do it. Must go on. Okay, we are given that function. It is a parabola that has been horizontally translated to the right 2 units. So let's graph this bugger. We'll make you blue. Parabola. Horizontally. Oh, I forgot the number. -2. Okay, so it's going to go there. The vertex is going to move to there, and then it's going to go over 1, up 1. And you're realizing why I really did not want to go here with you right now. There's my cursor. Over 2, up 4, go slow. Over 2, up 4, you can do it. When things have been like locked in place on Smart Notebook, sometimes the cursor I have found gets a little bit cranky. Ooh, no, that wasn't crankiness. That was yours truly. This is why I want to do this question. Um, that is the original function. F of x equals x minus 2 squared. Good. Awful, but okay. Let's get the inverse. I'm not putting you through watching me do the inverse. We're cheating to win, kids. Boom. Inverse is not a function right now, so I don't love the way this question is asked because it implies that this notation means that the inverse you're creating is a function. I would prefer like f inverse or I think it was f just -1. It was not saying of a function. I can't remember and it's bothering me. Okay, I'll figure that out. I'll look back at my really old notes. I'm at home. They're in my closet. This is perfect. Kids, I'm losing my mind. Okay, we're just going to leave that there. Restrict the domain of f of x. So the original, so that we're creating a function. So when we did this before, this is when I busted out the purple on one side, the peach on the other side, and that was like our restriction. So we want to do the same thing. Now, our restriction for this question is going to have to do, if we're restricting the original domain, it's going to have to do with that x value right there of 2. We're either choosing to stay on this side of it, or we're choosing to stay on that side. So we're either choosing purple or peach. So there are a couple of options for this situation. If we were deciding to go peach, our domain of our original function it would still be a parabola. That's fine. But we're only going to consider it when x is on this side of whatever line this is, which happens to be at 2. So if x is 2 or less, then we're going to have peach, and we will create an inverse that is a function. So if x is less than or equal to 2, such that when x is the set of the real. Where's the thing? X is the set of the real. Oh, I never said I had to be pretty. Okay, maybe I did in class. You can yell at me later. Let's look at the purple one. If we do purple, we're going to have to restrict the domain of the original parabola to only consider values that are at 2 or greater than, because we want to get purple. So if the original domain was this, x such that x is greater than or equal to 2, where x is the set of the real. I tried harder on that one for you. we've got our other scenario. So both this restriction that we put in right here on the original parabola or this restriction that we put on the original parabola would give us a function that is an inverse. Okay. Both of these restrictions would inverse that is a function. Okay. Find an algebraic model for the function. I just laughed because I got excited. This is going to be fun. I'm happy. You're going to groan. I'm happy. Okay. Here we go. Algebraic model. Oh no. Why it was f of x. I'm going to try and do this without minus 2 squared. Gotta go up. Gotta go up. Just to double check. Yep. Okay. So now we want to find an algebraic model for the function. Look at this. Trying to trick you. Saying you need to find it. So I'm going to get an equation that I could use as a function that's going to pass the vertical line test. Okay, we gotta be smart here. All right. But before we can be smart, we go into autopilot. We changed the things with the letters. We swapped the letters. We get things by themselves. All right, let's go. Y equals x minus 2 squared. We're going to swap our letters. Okay, we're taking the inverse right now. X equals y minus 2 squared. Now we've got to isolate for y. That's our next step. Take the square root, because if we can take a square root, that's going to cancel that squared out. But if you take the square root on one side, you're going to have to take the square root on the other side. And this is where your little brain skis are going to love me. Let's take the square root. By taking the square root, we get rid of the brackets. We get rid of the squared. All we're left with on this side is a y minus 2. Okay, grade 10. Okay, finding, oh my goodness, what was it? Finding the zeros of an equation by undoing vertex form. Okay, we are finding values of y, and when you take the square root of something, you have to consider both the positive and the negative root. So proper math is going to have you throw this little plus or minus right there, because we can't prove if it was a positive x or a negative x that was originally squared to give you that square root. Okay, so down here, now we just got to add 2. So because we've got an addition happening, I'm going to put it at the front. It just looks better. And then we've got the positive or the negative root of x. And that is not a function. I'm going to call it y, not function, because it's both, like right now, this graph is the square root function, both branches of it vertically translated by a factor of 2. If I wanted it for the translations, I would have put it at the end. But this function looks like this. So vertically translated, it looks like this. Okay, freehand, I'm much better. When I'm trying to connect things slowly, not so much. Okay, so we want to restrict, or we want to come up with an equation that makes this a function. So if I want only one of the branches, I pick only one of these. So we could make one of the functions, inverse equations, sorry, be 2 plus the square root of x, or you could make the other one be 2 minus the square root of x. And that gives you your individual branches of the square root function. So this is 2 plus, you're up here, 2 minus, you're down here. It's saying, like, if this was the equation, you've created a function. If this was the equation, you've created a function. If this was the equation, you've created a relationship. So don't get caught when you're doing your math. Oh my goodness. Okay, don't get caught when you're doing your math. When we were at this point, y equals, okay, I'm going to redo this, minus 2 squared. Switch x and y minus 2, take the square root. Don't get caught on this step here, because students will just put the square root of x and then they'll go y minus 2, and then they'll bring the 2 over, and they're just, by writing it like this, you're just considering the positive root. Because we assume, what number is assumed to be written in front of here if nothing's written? It's a positive 1. But when you take the square root of something, you really should be considering both the positive and the negative root. We talked about that when we were doing radical work in the beginning of the semester, and it's kind of coming back to haunt you right now. And it's not gone. We're getting into quadratics next.